A six-cylinder two-stroke engine coupled to a controllable pitch propeller develops a maximum rated power output of 9,500 kilowatts when running at a speed of 120 revs per minute with an air-fuel ratio of 45:1. 45:1 is the same thing as 45/1, that is 45, and consumes air at a rate of 77,000 kg per hour. If the bore of the cylinder is 750 millimeters and the stroke is twice the bore, calculate the brake effective pressure, the total fuel consumed in 10 days, the brake specific fuel consumption, and the power developed when the engine is running at 300 revs per minute. So in the question we were given our number of cylinders to be 6. For a two-stroke engine for two-stroke, we know that our K is I. The brake power of the engine was 9,500 kilowatts and engine speed 120 revs per minute. We know that we're converting rev per minute to revs per second. That is divided by 60 to give you 2 revs per second with an air-fuel ratio of 45. The mass flow rate of air 77,000 kilograms per hour. We're converting this per hour to seconds, so that is dividing by 3,600. Remember, converting hour to minutes, converting hour to seconds is divided by 3,600. Converting minutes to seconds is divided by 60. So hours to second divided by 3,600 to give you 21.39 kg per second. Our diameter was given as 0.75 meters, and we know that the length is twice the cylinder, that is twice the diameter of the cylinder, that is the bore. So the length or the stroke is given as 2d. So we take length is equal to 2 times our d, that will give us 1.5 meters. Now, in the question we were asked to look for our brake pressure, our brake mean effective pressure, and we know that WB is equal to PB lengths. We were given WB in the question, and we were given all the parameters necessary to find lengths. So what we don't have is PB. So let's make PB subject to formula, that is WB over lengths. We put in our value for WB, our lengths, and our area, times our engine speed, times our K, times our S, to give you 1,194.6 kilopascals. The next thing we were asked to look for was our total fuel consumed in 10 days. So the formula for the total fuel consumed in 10 days is equal to big M, this is big M, not just small m, big MF, this is total fuel consumed in 10 days, is equal to SFC times W times, times 24 all over 1000. But to get SFC, we know SFC is equal to MF times 3600 all over W, that is power. Okay, so we don't have our mass, this small MF, we don't have our mass flow rate of fuel. We have a W that we can use, which is our brake power. Remember I said when it's not specified, the SFC is not specified, use your brake power. So we're going to use our brake power here as our W. So let's try and find MF. So we can now recall that air fuel ratio is equal to MA over MF. Making MF subject to formula, we have MF is equal to MA over air fuel ratio. Our MA was given in our parameter, so was our air fuel ratio, which is MA is 21.39 all over our air flow ratio, which was 45, will give you 0.475 kilograms per second. We can now say that SFC is equal to 0.475 times 3600 over our power, it's our brake power here, 9,500 to give you 0.18 kilogram per kilowatt hour. Now the total mass of fuel consumed in 10 days is going to be given as your SFC times your power times 24 all over 1000. That will give you 41.04, and your total fuel consumed in 10 days is given in tons. So your answer is going to be in tons. Then the second part was find the brake power if the engine was moving at a different speed. That is, in this scenario, the engine speed is 300 revs per minute. So we're converting the 300 revs per minute to revs per second. That is divided by 60. So that's 5 revs per second. So we already have our PB. We found our PB before. PB times our length times our area times our new engine speed, which is here. Before it was 2, now it's 5. This is our new engine speed times the number of cylinders times our kind of stroke, which was 1. That will give you 23,749 kilowatts. So that's your final answer.